Morning friends of class 12th. Today we will learn some tricks about Lorentz force. You have already known the equation of Lorentz force, and now we are going to solve some very simple tricky problems based on Lorentz force. See, what is Lorentz force? First of all, it is a magnetic force that is applied on the particle, that is F Q into V cross B. Okay, F is the force applied on the particle, V is the velocity of the particle, B is the magnetic field, and Q is its charge. Okay, and what is the radius? The radius of the particle, which we also known as the radius of the particle in moving magnetic field. The equation of that radius is equals to R is equals to mv by bq, or you can say mass into velocity is what? It is momentum upon b into q. What is m? Mass of the particle, v is the speed, b is the magnetic field, and q is the charge of the particle. Now in these tricky questions there is nothing involved for the Lorentz force, so I am rubbing this equation. We will be using only this equation to calculate some tricky problems. Now see, the question given to me is about the radius. Let me rewrite it. Radius of gyration mv by bq or P over BQ. Okay, now what I have one electron which is entering this magnetic field with velocity V. Where is the magnetic field? This is the magnetic field shown by dots. You know what is a dot? Dot means the direction is outwards. Cross means the direction is inwards. So here, what is the direction of magnetic field? It is dot. So it is outwards, this way. And I have a proton which is entering this magnetic field. Alright, now the question asked to you is that what will be the path of this electron? So, Lorentz force F is equals to Q V B sine theta. How to find the direction of force on this electron and this proton? Okay, first we go for proton. The charge of proton is positive. So, which rule is to be used? We use the Fleming's left hand rule to find the direction of force. And what do the fingers indicate? Force, field, current. I am repeating, force, field, current. This finger should be in direction of current, this finger should be in direction of magnetic field, and the thumb will show the direction of force. Alright. So, this finger, the first finger, should be in direction of magnetic field. Where is the magnetic field? It is outwards. This finger must be in direction of current. Where is the current going? Current is the direction. The direction of current is the flow of positive charge. जो positive charge के flow होने का direction होता है वही अपना current का direction होता है. So, this finger has to go like this. So, magnetic field is outwards and direction of current is like this, towards this side. Okay, and what is the force? The force is in downward direction. The force is in downward direction. So from here, this is the direction of force, and when velocity and force are perpendicular to each other, what is the resulting path? The resulting path is circular path. So this proton is going to cover a circular path in which direction? Like this, okay, clockwise. Now coming to electron. Okay, electron is also moving in the same magnetic field with the same velocity v. What will be the force on this electron? The direction of force on this electron. So see, electron is negatively charged. Electron is negatively charged. So now how to find the force? Again, force, field and current. If electron is going this way, the current would be moving in opposite way. So direction of current is this. The second finger should be in direction of current. So this is direction of current. And now this finger should be, the first finger should be in direction of magnetic field, which is outwards. So this in direction of current, second finger, this in direction of magnetic field, first finger, and this thumb is going to show the direction of force, which is upwards. So here the direction of force on the electron will be upwards, and so when velocity and force are perpendicular to each other, the motion is what? The motion is circular. So electron is going to move like this. Okay, proton moves like this, electron moves like this. Got it? So we have found the paths of this proton and this electron. Now coming to the calculation of their radius. Okay, what is the ratio of their radius? See, if in the question it is given that electron and proton are entering the magnetic field, mark my words, listen to the words very carefully. The question given to you says that electron and proton are entering the magnetic field with the same momentum. If their momentum is same, are they entering the same magnetic field? Yes. Their momentum are same. Their momenta are same. Yes, it is given to you. And what about the charges? Their charges are also equal in magnitude. So what will be the radius in this case? The radius of proton and radius of electron will be equal. Radius of electron will be equal to radius of proton. Why? Because momentum same है, magnetic field same है, charge भी same है, तो जब तीनों चीजें same है तो उनका radius भी same होगा. All right, this is the first thing. But if the question is twisted like this, question को क्या किया अभी? थोड़ा twist कर दिया. Now it is said that they are entering the magnetic field not with equal momenta but with equal velocity. They are not moving inside the magnetic field with the equal momenta, but they are moving in equal velocities. So how to solve this? R is equals to mv by bq. Okay, now see, velocity of proton is equal to velocity of electron. Okay, mass of proton is actually 2000 times the mass of electron. ओके, मतलब प्रोटॉन जो है वो इलेक्ट्रॉन से 2000 टाइम्स हैवी होता है. ये आपको याद भी रखना है. ओके, द एग्जैक्ट नंबर इज 1846 और समथिंग लाइक दैट, बट अप्रॉक्सीमेटली वी कैन टेक द मास ऑफ प्रोटॉन as 2000 times the mass of electron. Okay, now we find the radius. Radius of proton divided by radius of electron. इनका दोनों का जो रेडियस है उसका रेशियो फाइंड करेंगे अपन. So what is radius of proton? It is given as mass of proton into velocity of proton upon bq. Okay, radius of electron, mass of electron into velocity of electron upon bq. ठीक है, क्या होगा? Q, charges are equal, they will cancel. Magnetic fields are equal, they will cancel. Their velocities are also equal, they will cancel. What remains is only this, mass of proton upon mass of electron. Now see, what is mass of proton? Mass of proton is equals to 2000 times the mass of electron, and the denominator you have got mass of electron. These will cancel out. So what do you get? Radius of proton will be 2000 times the radius of electron. Yani ke if proton covers a circular path, its radius will be this big radius, and the radius of electron will be very small, chota sa circular path, because their radius have a lots and lots of difference in their magnitude. Okay, now we replace this electron with alpha particle. Okay, we replace this electron with alpha particle, and again now what we are going to find? We are going to find the ratio of radius of alpha particle and the radius of proton. Okay, so first of all, when this is alpha particle, it goes like this. How to find the direction of force? Force, field, current. Where is current? It's like this. Where is the magnetic field? It's outward. So what is the direction of force on this alpha particle? It's downwards. पहले इसको ठीक कर लेते हैं. The force will not be upwards. The force here also will be downwards, and this alpha particle is also going to move in a circular path like this. Okay, this is positive. Alpha particle is also positive. Just a minute. If you do not know what is an alpha particle, let me tell you, an alpha particle is a combination of 2 protons plus 2 neutrons. Okay, alpha particle is a combination of 2 protons and 2 neutrons. दोनों को जोड़ दिया. So what exactly do you get? You get alpha particle. Plus you can also say that this alpha particle is nucleus of helium atom. Helium atom, you know what is the atomic number? 2. And what are the number of protons and electrons? Helium maybe there are 2 protons and 2 electrons. So whether in the question it is given that nucleus of helium or it is given that it's alpha particle, they are the same things. Alright. Now radius of alpha particle upon radius of proton. Let us calculate. Rewrite this formula again for alpha particle and also for proton. So what you get is mass of alpha particle, velocity of alpha particle, magnetic field and charge of alpha particle. Proton, mass of proton, velocity of proton, magnetic field and charge of proton. Okay. Now what is given to you? In the question it is given to you that alpha particle and proton are going with same velocity. Velocity of alpha particle is equals to velocity of proton. This thing is given to you. How to find the ratio of this radius? See. So the first thing is going to cancel is magnetic field. दोनों का magnetic field एक ही magnetic field में है दोनों. So BB will cancel. Their velocities are also equal. So you can cancel their velocities also. And what you get is mass of alpha particle upon mass of proton into, this goes up, denominator of denominator shifts to numerator. So QP, that is charge of proton, this will go down, this will be charge of alpha particle. Okay, now you can say देखो proton और electron, sorry proton और neutron दोनों का mass एक जैसा होता है. If their mass is same, that means are they same particles? No, they are not the same particles, but their mass is almost same. Clear? So in one single proton, what is the mass of one single proton? It is whatever it is. But if we take this as 1, this will become 4. Why? Because कितने protons हैं? 1. Alpha particle में कितने protons हैं? 2. और क्या है? 2 neutrons, 2 और what is their mass? Their mass are nearly equal. So this is once the mass and this is 4 times the mass. This is 4 and this is 1. Then here you have to write the charge of proton. What is charge of proton? It is E. And what is charge of alpha particle? See, neutrons, they do not have any charge. The charge is only with 2 protons. So alpha particle में कितने protons हैं? 2 protons. So what will be charge on them? The charge on them is 2E. That is cancelling. Okay. This is also cancelling 2s are. So what is this? 2 by 1. So radius of alpha particle will be twice as the radius of proton. Okay. You have to get ready for these type of questions because they are frequently asked for 1 mark or so.